Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we will introduce you to electronics, to electronic signaling, AC and DC signals, and then in future videos we'll be looking at different details about those signals. Start with, I have on my screen an AC waveform. This is a simple sine wave. And this waveform that I have that I'm showing, if you notice, it's got a period to that the waveform repeats. This is an analog signal. Analog signal meaning its intensity or its value varies over time. So it's very high here, it crosses zero here, very low, something in between here. So over the course of time, this analog signal, its values or its intensity changes. When we're talking about waveforms in electronics, we're going to measure the height of that waveform typically in voltage or volts. We could be measuring current, and if we're measuring current, that would be measured in amps. But for the most part, what we'll be doing is talking about volts. Well, the current or the number of amps is definitely related to the number of volts. So we have our analog or AC waveform. The best example of an analog or AC waveform that you're used to, which is a sine wave, is actually the power coming from your power company. That is an AC analog waveform. In the United States, that's typically running at 60 hertz. We'll talk about hertz later. And it's at 100, I started right 120 volts. So in the US, we typically work with 60 hertz, 120 volts. Some countries work with 50 hertz, 240 volts. So those things could be different, but the power supplied by your power company is typically where we see our analog waveforms first. Now, in addition to our analog waveforms, we have digital waveforms. I seem to have lost my digital waveform, so let's go in here and let's just draw one. If I'm drawing and I want to draw one, if I have, say, an X and an X and a Y axis, a digital waveform usually is either 0 or it's at a value of the maximum voltage, back to 0, back up. And that digital waveform, those are the two values you typically see with it, a high and a low. Now, in terms of voltage, this may be 5 volts. This may be 5 volts, or it could be some other voltage, and this would be 0 volts. What we normally indicate or say is that whenever it is at the 5 volt point, that is a logical or a digital 1. When it's at the 0 voltage, that is, put that in the wrong place, that is a 0. That is a 0. I guess I am going to have to learn to write and talk at the same time. So that is our analog waveform. Now, as we start looking at signals, most signals are not that nice, pretty sine wave that we just saw. Most signals have some sort of distortion, and you can see here in this graphic, this image, that we have some distortion in our signal. It's coming up there. You can see it's a little bent there. It reaches its peak. There's a little bent place there on it. It doesn't come all the way down here. Normally, as we're receiving digital waveforms, or analog, I'm sorry, analog waveforms, there's distortion in it and it's not a perfect signal. And we're going to see over the course of the next few videos how we handle that and how we look when we need to deal with it and convert it to a digital waveform. And one of the things we do in converting to a digital waveform is we do something called sampling. And sampling is basically taking an analog signal and at different points or periods of time taking a sample or measuring what the value is at that point in time. So these are different samples, and we use those samples to build a digital representation or representation of that analog waveform. One of the ways we do it, if you listen to a compact disc, the compact disc is playing the music back. The music is stored digitally, and what they did was they took the analog waveform of the music and they did sampling at various intervals during that performance of that sound. And as you're listening to me, that's what's happening. My voice is analog. My voice is high, low, different values, louder, softer. But what the computer's doing is it's capturing the audio. It is every so often it is sampling or just grabbing whatever the value is at a certain period of time, and it's using that to build or regenerate the audio waveform when it plays back. Now we're going to talk more about analog and digital signals in the next video. After that, for quite a while, we'll be talking about just digital videos. So I'd like to thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss the future episodes. And please check out and subscribe to our other Dan on Tech channels and playlists. Thank you.